Hello again. So what is a computer and what does it do? So a computer is an electronic device. It's a programmable device that accepts data from the user, performs operations on that data, and gives you the output as an information and stores that data for future use. So a computer is a programmable device, meaning that whatever you want to you want computer to perform, you can give those instructions. Like, for example, robot is a example of the computer. So if you want the robot to assemble your car or do something, you can give those instruction in form of a program, right? So that's what we mean is the computer is programmable. It's an electronic device. It accepts the data, performs some operations on that data, gives you the information, and store that data for the future use. So those set of instruction that you are going to program, this is called programs or software, right? And the programmers have to actually do that job. So a computer is a programmable electronic device that accepts data, it performs operations on that data, and stores that data for the future use. So there are 5 basic operations that a computer performs, that any computer performs. One is it accepts input, right? Whatever it accepts as an input, we call it a data or a raw data. For example, if you want a computer to give you the sum of two numbers, like for example, 7 plus 5. So what you will do, you will ask the computer to add 7 and 5. So whatever you are going to say is an input, right? And then what the computer will do, computer will perform the addition operation on that, right? So it will actually add 5 and 7 and manipulate some results that is actually 12, and it shows you the result 12. That is the output, and it's the information for you. And then that result you can store for your future use, and or you can communicate that result to somewhere else, to your friends or somewhere else. Let me give you one more realistic example. So for example, you want to search something from the Google, or you want to search actually your credit report, right? So what you will do, you will go to check your credit report, you will input your social security number. The computer will perform some operations to gather the relevant information based on your input, based on your given data. It will gather the results, it will manipulate that, perform some operations, and presents to you your credit report. That is your output, or we call it the information, right? And then that report you can store it for the future use, or you can simply communicate with someone else. So 5 basic operations that we call IPOS cycle, or we call input, processing, output, storage, and communication, right? So here is the example that we just discussed. You just need to give 5 and 2 input from the keyboard. Computer will perform the operation, will display you the output that you can store for the future use, or can communicate with your peers. So what is data and what is information? So you should be clear that the data is the raw and unorganized facts. Like I just told you, your credit data is stored in different machines and different formats in different computers. So they are placed many on different you can say the different organizations. So once you ask the computer to gather the data and present you the report, it will gather the data from different maybe your credit card providers, or maybe from the other agencies that actually calculate your credit score, and presents you the information. So the data are the unorganized facts. So for example, if you ask Google, that is one of the example of the computer program. So if you ask the program to show you the best restaurant nearby, so what it happens, it actually, you are giving the input to the user. So the information of the restaurants are kept on their websites in different web servers, right? So what your program will do, that will collect the information for you and give you the information that these are the restaurants nearby to you, right? So that's called the information. So information is data, but it has been processed into a meaningful form, right? Information processing is the conversion of data to the information. So basically, if we summarize this all, what actually is a computer and what actually computer does, it does only one thing, basically. What? It actually converts the data into information, right? But it actually performs these 5 operations for that: input, process, output, storage, and communication. But the actual responsibility of a computer is to convert data into the information, right? So here is some history about the computers, computer then and now, pre-computers and the early computers. We know that the computers are fairly recent invention, right? They are introduced in 1940s, 1946, 47, right? So the history of computer is often referred in terms of its generations. So each new generation is characterized by a major technological development. So pre-computers and the early computers before 1946, as I mentioned. So before 1946, it was an era that where no electronic computers were there. So they are called pre-computer generation, like abacus, slide rules, mechanical calculators were used, punch card tabulating machines and the sorter were used as calculating devices. The first generation of the computer starts from 1946 and lasts until 1957. In this first generation, the computers were invented like in ENIAC and UNIVAC. So these computers were enormous and they were powered by the vacuum tubes. The technology that was used for these computers was the vacuum tubes, right? But the problem with these computers was they consume a lot of electricity and they were very huge in size and they produced a lot of heat, right? So these computers, and they obviously were very slow. They process some instructions per minute or per hour, right? So they were just the first generation and the start or the beginning of the computers that we are looking today. In the second generation, that starts from 1958 until 1963, in transistors were used, transistors were invented. So the vacuum tubes were replaced with the transistor for processing the transactions. So computers become, because the size of the transistor is smaller than the vacuum tube, so the computers become smaller, they become more powerful, they become more cheaper, and they become energy efficient because the vacuum tubes consume a lot of light. Transistors were energy efficient, right? And they become more reliable. So in this generation, punch cards and the magnetic tape were used to give the input to the computers. Like no keyboard was used like we are using nowadays, no mouse was used at that time, like to point the input. We see that was introduced in the third generation, but in the second generation, the punch cards and the magnetic tapes were used for the input. And as well as for the output, we were storing the output on the punch cards or we're simply printing it on the paper. Magnetic tapes were used for the storage purposes. In the third generation that started in 64 until 70, ICs were used. So integrated circuits that actually composed of many transistors. So previously we were using vacuum tube, then vacuum tube was replaced with the transistor. Now we are replacing this transistor. We are actually encapsulating those transistors inside in one integrated circuit, IC, right? So we used ICs, which consist of transistors and electronic circuits on a single tiny silicon chip. So because of this, the size of the computer become more smaller, it become more reliable, it become more energy efficient, and it become more fast. So first time the keyboards were used for the input and monitors were used for the output in the third generation. And the hard drives were used for the storage. So the hard drives started from the third generation. In the fourth generation, that started from 1971 and last until now, even though we have more powerful computers now, but it falls in the fifth generation. We'll see in the next slide. But in the fourth generation, microprocessors were used. So instead of using the simple ICs, we invented microprocessor, and with microprocessor is composed of the ICs itself. So which contain the core processing of an entire computer on a single chip. So only one single chip, instead of having a huge computer, one chip is doing all the processing in the fourth generation, right? And keyboards, mouse are used for the input, monitors and printers were used for the output. Hard drives, flash drives, optical discs are used to store, and these are still, we are still using flash drives and the optical devices for the storage. Network and the internet was developed. So internet and the network started in the late 90s, early 90s. That is actually fall in the fourth generation. So from here, actually the computers became accessible for everyone, for the home users, for the individuals, and for the businesses. So in the fifth generation computers, they are termed as the AI computers, or the artificially intelligent computers, right? So the most commonly defined as being based on the artificial intelligence. Some aspects like voice and touch input are used today. We are giving input and we are getting the output in terms of voice and touch, right? We all have touch screens in our hand. We all talk to Siri, or we talk with the Alexa. We give them the instruction through voice to perform our dedicated tasks. So future computers may be different, such as they may be optical computers. Optical computer means the computers that are working with the speed of the light, and they are working with the light technology, optical technology. So tiny computers that utilizes nanotechnologies. Computers are becoming more and more smaller. You can see one phone that you are having in your hands is nowadays much more faster and much more powerful than the computers of the first generation and the second generation and the third generation. Even in the third generation, you can see, even in the earlier fourth generation. So I remember the computers when we started working in that back in late 90s or early 2000. So the speed of the computer was much slower than today's mobile phone, right? So they are becoming more smaller and more powerful because of the utilization of this nanotechnology. We are having these small devices now. General purpose computers built into everyday devices. So these computers, general purpose computers, will be right now, before today, you can see the special purpose computers are built into the electronic devices or the everyday devices. But the future is the general purpose computer will be in the everyday devices. For example, you will be having a refrigerator with a console panel where you can watch movies, where you can play games, where you can do your business, where you can take online class, right? So one everyday device is becoming, you can see the cars nowadays, they are equipped with the latest computers, right? So the general purpose computers are becoming integral part of the general household devices or the everyday devices. That's the today of the computer, and this is the future of the computers. So computer is basically composed of two things. One is the hardware, another one is the software. Hardware are basically the physical parts of the computer, the tangible parts of the computer that we can touch, and we can actually see the hard part of the computers. So there are three, and the software are basically the intangible parts of the computer that you cannot touch. But hardware and software both are compulsory component for a computer to work. Like, for example, if you have a hardware and you do not have a software, that hardware is useless. You cannot actually operate that hardware. You cannot make maximum of that. And if you have a software and you do not have a computing device, hardware, your software is useless. You cannot use it, right? So there are several examples. One of the classic example is your own body. Like myself, I am composed of hardware and software. That's by nature. So our body, my hands, my face, my everything is the hardware. But I do have a software that is called soul. right? So if my body is there, and the soul is not present, this will not work, right? So this hardware is useless when the soul is departed. But on the other hand, if you have the soul, but you do not have the hardware, I'm sure you will run away when you will see a soul without a body. So both things are necessary to form a human, right? The body and the soul. Similarly, to form a computer, you require a hardware and a software. So tangible parts and the intangible parts. So let's talk about the hardware first. There are three types of the hardwares: internal hardware, external hardware, so the internal hardwares are the hardware that actually are inside the system box or the system unit, right? Like the motherboard, like the processor, like the RAM, and these all are called the internal hardware. The external hardware are the hardware that you connect externally with the system unit, like for example, your keyboard, like mouse, like your monitor, like your headphone. These all are the external hardware that you are going to connect with the computer. So hardware devices are associated with all 5 operations. Remember the operations: input, output, processing, um, storage, and communication. So hardware is associated with all 5. We have the input devices, we have the output devices, we have the processing devices, we have the storage devices, we have the communication devices. So all 5 we'll see one by one in detail in the upcoming lectures. So input devices, here we have the introduction, but we'll see the detail of those later on. So input devices are used to input the data to the computer, like the keyboard, mouse, scanner, cameras, microphone, pen, touchpad, touch screens, fingerprints, readers, etc. The processing devices are basically the central processing unit, or we call it the CPU, right? So that performs the calculation and control the computer operations. So CPU is basically the brain of the computer, or you can say it actually controls everything. We'll have a very detailed discussion on the processing devices in the next lecture. So it also includes the processors, additional processors like the GPUs, graphical processing units, and memory that we call RAM and ROM, right? Output devices that present results to the user. That includes monitor, printer, speaker, headphone, and etc. Storage devices that are used to store data on or access data from a storage media like CDs, DVDs, hard drives, USB drives, pen drives, and these all are the storage devices. Communication devices allow users to communicate with others and electronically access remote information. So your computer want to communicate with another computer. You want to access remote files on your computer. So you need to communicate with the other computer that hosts your files, right? So that there are several devices that we require for this communication, like the modems, the network adapters, the routers, and many others. We'll see all these devices, specifically storage and the communication, in detail as a separate lecture. Here are some examples of the computer hardwares. You can see printer, keyboard, mouse. These all are the hardware components. So software is a program or set of instructions used to tell the computer hardware what to do. Hardware is there. You need to operate that. Your body is there. You need the soul in order to operate this body, right? Similarly, the set of instructions are required, the programs are required, software are required for computer hardware and tell the computer what to do. So we basically have 2 types of the software. One is called the system software, another one is called the application software. System software includes the operating system as well. So system software means that actually holds the whole system, that actually guide, instruct, operate your hardware. That's called the system software. So the operating system, which starts up the computer and controls its operation. Without an operating system, a computer cannot function. The operating system boots the computer and launches programs at the user's direction. There are several functions of the operating system. Again, we'll be discussing operating systems in detail in a separate lecture later on. So most use graphical objects to interact with users, like icons, buttons, tiles, and there are different interactive and the graphical interfaces provided by the operating systems. That includes Windows, operating system X by the Mac, Linux, Android, iOS, and many. So the Windows desktop is the work area for working Windows PCs, right? So you can see this, we all know that this desktop is the area where we can interact with the computer and can access the computer resources. Application software, in short, we call them apps, perform a specific task or application. For example, you go to the bank, you want to open up an account. The banking software is an application software that performs a specific task for the banks only. You went to the hospital, you want to book an appointment to see a doctor. That software is as an application software of the hospital or a clinic, right? You cannot book a doctor's appointment in a banking software, or you cannot view your bank account statement in a doctor's office or the doctor's application software. So they are designed for a specific task, for a specific purpose, right? There are several examples. I mean, for example, you are going to edit the photographs, you are going to send and receive the emails, you want to design some architecture or the design. For all of such applications, we have different application softwares, right? Now, the computer users and the professionals. So computer users or the end users use a computer to perform tasks or to obtain information. These such type of users are called the end users, and the majority of the computer users are the end users who use the computer to get the information for that, who want to read the news, for example, right? And the professionals, computer professionals, they include programmers who write the computer programs and the software, analysts, they design the whole computer system for your organization or for the business organizations. Computer operations personnel who manage day-to-day computer operations, who are to set up to upgrade the computer, to do the maintenance and all these things. Security professionals, here comes your job. So security personnel, they secure the computers and networks against the hackers, right? So the security professionals or the security specialists, they are really in demand. They are the actual persons who enables the businesses to restore and to manage their data without to have their data without any without any worry, right? So there are different types of the computers that fit everyone's need. So 6 basic categories of the computers are embedded computer, mobile devices, personal computers, servers, mainframes, and the supercomputers. Let's have a look, a brief description for all of them. So the embedded computers are designed to perform a specific task or function for the product in which it is embedded. So you can see the microwave oven at your home. It comes with an embedded computer. You can see a refrigerator at your home. You can see a thermostat at your home. It comes with an embedded computer. They are designed, they are small computers, tiny computers. They are embedded with the device and they are designed for a specific task. And they perform only that task. They are not the general purpose computer, right? So they comes with the household applications, sewing machines, treadmills, and they are the you can see the self-driving cars. One of the example that is in the diagram, Google's self-driving car, right? So it comes with the computer. You just set your destination. It will drive you to that destination. Mobile devices, we all are familiar with that. You all have the mobile devices. So it's a mobile device is a very small device with some type of built-in computing or internet capability. So typically has a small screen and keyboard. Many use voice or touch input, can perform internet searches, pay for products, and view documents. It includes smartphones, handheld gaming devices, tablets, and smartwatches. Modern trend, Apple Watch, that is a mobile device. It is designed to work in conjunction with an iPhone for much of its functionality. So you can launch apps and select options via touch. It also supports voice input. Apple Pay enables you to make payments via stores, contactless payment terminal. I'm sure many of you are using this Apple Watch. Another trend, you can see the industry is moving towards digitization. So smartphone driver license. This is one of the examples. Several states are currently testing and likely implementing digital driving licenses. So most of the documentation are becoming now digital. So this is one of the example. So digital driving licenses resembles your paper driving license and contain the same information. DDLs are mobile app that can contain additional features as well. Some issues need to be resolved before widespread use. So it is undergoing in the testing phase. It will be available in near future. So you do not need to go to the DMVs anymore to renew your driving license, or you will not be able to get the car driving license that you can easily misplace. So instead of that, you can simply have the digital mobile driver license, right? The third type of the computer is the personal computer, or in short, we call it PC. A personal computer is a small computer designed to be used by one person at a time. I'm sure every one of you have the personal computer. Sometimes we call it the desktop computer. The reason is because we are placing it on the desk, we are sitting in front of it, and we are working on that computer. So originally called a microcomputer, it is available in different sizes and the shapes. One of the sizes is the desktop computer. You can sit next to the desk. It comes in a tower case or a desktop case, or as an all-in-one PC. You can get it by the Macintosh, that is the Apple Mac, or you can get the all-in-one from HP, Dell, and many other brands are there. This is not portable because it is heavy in size and you need the electricity. It is not coming with the battery, so you need it is not the portable computer, right? Another portable computer is uh, okay, so the personal computer, and the other category is the portable computer. A portable computer is designed to be carried around easily. One of the classical example is your laptops or the notebook computers, right? So they are designed specifically so that you can easily carry it with you, and you can open it up. It comes with the battery backup. It comes with the necessary connections, and you can simply use that. Tablet computers, hybrid notebook tablet computers, and simply the notebooks. Here are some of the examples. You can see the notebook. The Chromebooks is one of the example of the notebook. Your tablets, iPad is one of the example, and the hybrid notebooks, meaning that you can use them as a tablet or as a notebook, whatever you want. You can simply disassemble the screen from the base, and you can use it as a tablet. And this is called hybrid notebook tablets. A thin client is designed to utilize a network for much of its processing, like the Chromebook. So thin client is a computer that has limited processing power. It actually connects with the network to utilize the network resources, network power, network storage, network processing, and everything over the network. So the reason, the advantage of designing this thin client is the lower cost. Obviously, you will be having lower equipment with you, lower processing power with you, lower battery backup with you. So that will lower the cost of the equipment. It increases the security since you do not have the data on your laptop. The data is on the cloud or on the network. So it's more secure. It's easier to maintain. So but there are some disadvantages that include limited or no local storage. So for example, if you do not have the network connection, you are not able to access your data or the processing. You are unable to process the task. An internet appliance is an ordinary device device that can be used for accessing the internet. So if you just want to access the internet, that is called the internet appliance. So some use apps to deliver news, sports scores, weather, music, and other web-based information that may include smart TVs, refrigerators, and other appliances. As I just mentioned, the appliances are becoming the smart appliances. They are being connected with the internet. They are becoming the general purpose computer. So they are also called the internet appliances. Server computers. A server is a mid-range computer used to host programs and data for a small network. So basically, a server computer hosts the data and the programs, software for different of its users. So users can connect via a network to the server and can use its data, its resources, its processing power, its programs, right? So user connect via network with a computer, thin client, or a dumb terminal. So what is the difference between the dumb terminal, thin client, and a computer? So remember, computer is a full-fledged computer. That might be your laptop, that might be your desktop computer, right? Thin clients are designed with the limited local storage, with the limited processing power, right? They are very limited in as compared with the computers or the laptops. Dumb terminals are the dumb terminals, meaning that they do not have anything. They do not have their own memory. They do not have their own processor. They do not have their own storage, nothing. They are just the output devices or an interface to connect with the network. So whenever you connect, they are actually connecting with the server, and you are going to get the information, everything from the server, all the processing, all the storage, and everything. So the dumb terminals are only used for the input and the output. Virtualization is becoming popular. Virtualization refers to creating virtual rather than actual server environments. So we'll see the virtualization concept in detail when we'll be covering the network part as well in detail later on. But instead of having these actual server computer, what happens is we actually create a virtual server computer with the help of this virtualization technology, right? This is used to share a server for increased efficiency. Desktop virtualization delivers a user's desktop to his or her current device. For example, I am sitting in my office, I'm using my computer here, but I can access this desktop computer right from my home. That is in another area, that may be another city, or maybe another country, right? Wherever I can have the access to the internet, I can access this server desktop computer on my other devices with the help of this virtualization technology, meaning that this computer is physically present in my office, but virtually I will be able to access it with the help of this virtualization technology. Mainframe computer, these are powerful computers, right? They are also used for the server computers. So this is a powerful computer used by many large organizations to manage large amount of centralized data, right? So they are powerful. They can handle hundreds of users. The large organizations where the users are, there are many users, so they use the mainframe computers to manage their networks. So often used in hospitals, universities, large businesses, banks, government offices, and many other places. They are located in climate-controlled data centers and connected to the rest of the company computers via a network. So because they are big computers, they are expensive computer, they have more processing, so they emit more energy. So climate control environment and the data centers are required for them. So they run programs to meet the needs of a wide variety of users, as well as large processing tasks during off hours. Often uses virtualization. So used for new and emerging needs, such as processing data from smart meters and running social networks. Also called high-end servers or enterprise class servers. So the another name for term for mainframe computer is high-end servers or the enterprise class servers. Here you can see the IBM mainframe computer servers. They are implemented in to process the task. Supercomputers. A supercomputer is the fastest, most expensive, most powerful type of a computer. So generally it runs, these supercomputers are designed for a specific task, one program at a time. And generally it runs one program at a time as fast as possible. So new applications include hosting extremely complex websites and three-dimensional applications. Where the data is complex, it requires huge processing, and we need immediate results. We use the supercomputers. So it can cost several $1 million for a single machine, for a single supercomputer. So tend to be very large and contain a large number of processors. Titan is one of the fastest computers in the world. So it contains more than 300,000 processors. So the peak speed is 27,000 calculations per second. So the environment where we require these much of calculations, like scientific applications, for scientific purposes, we use supercomputers. Here is one of the diagram of the Titan that is a supercomputer. So it have immense processing speed and capabilities. So what is a computer network? And or what is the internet? So a computer network is a collection of hardware and other devices that are connected together, that the users can share hardware, software, and data. Users can communicate with each other. Users can share an internet connection. Most computers and mobile devices today connect to a computer network, right? So almost every device today connect to a computer network. So an example includes small and large business networks, school networks, home networks, public wireless networks, and mobile telephone networks. So network is a collection of hardware and other devices that actually are connecting together. They are connected together. Many computers, standalone computers, when they connect with each other, this becomes a network. So here is one of the example of the network in a small organization, tablets, computers, printers, many devices can be connected with the network. So what is the internet and the World Wide Web? The internet is the largest, most well-known computer network in the world. So the abbreviation of the internet is international network. So it's the network of networks. It's the largest well-known computer network. So individuals connect using a internet service provider, or in short, we call it ISP. So ISPs connect. So for example, if I am a user, I will connect to the internet using the internet service provider. For example, if I'm using T-Mobile, T-Mobile is my internet service provider, right? Or if I am connecting using the Wi-Fi provider, FI Wi-Fi, so that is my service provider. So that service providers are then connected with the backbone regional network, and those regional networks are connected to the backbone network, which connects to the internet. So this whole that's the whole hierarchy that becomes the internet. So World Wide Web is one resource, a vast collection of the web pages available through the internet, right? So web pages typically contain hyperlinks. Website is a collection of web pages that are stored on the web servers. So web pages are viewed using a web browser. We all know that many web browsers are available. So web pages offer a wide variety of information, and everyone is using web browsers, and there are many activities that we perform on using the web browser and to access the web pages and the websites. So how you are able to access a network or the internet? So you need a network adapter to connect, right? That could be a wireless adapter, or that could be a wired adapter. Then you need to have a username and a password. We know that. Then internet connection, you can establish it using direct connection, or you can use a dial-up connection, right? So internet address is internet address access accesses the resources on the internet. So any device, any resource on the internet has an internet address. With the help of that internet address, we access that device or a particular resource or a particular web page or a website or anything, right? So there are three types, most common types of the internet addresses. One is the IP address, right? That we need to identify the computers or the physical devices. URLs, that are the addresses to identify the web pages, and the email addresses that are used to identify the humans or the person. So three addresses: internet address is to access the resource over the network, three addresses: IP address, URLs, uniform resource locator, and the email address. And these three have IP addresses are used to identify the computers, URLs are used to identify the websites, and email addresses are used, or the usernames, they are used for the humans or the persons. So IP address, again, it has two different versions. One is called the IPv4, another one is called IPv6. So both are, in practice, both are being used. So it's a numeric address that identifies a computer such as 134.170.185 and 46. So this is called an internet protocol address. A domain name is a name that corresponds to an IP address. So it's really difficult to remember the IP address every time. For example, if you are going to access a Google server, so it's really difficult to remember the IP address of the Google. So instead, we use the domain names. Google.com is a domain name. Microsoft.com is a domain name. FIU.edu is a domain name that actually corresponds to a particular IP address. So instead of remembering the IP address, we remember the domain name, right? So domain name corresponds, they are mapped to the IP addresses. So the top level domain is the far right part of the name, identifies the type of the organization or its location. And then there are different types of these domain names. You can see the TLD or top level domain. They are used to classify, to categorize different. For example, .com is used for the commercial, .edu for education, .gov for government, .ind for the international treaty organization, .mil for military, .net for network providers, .org for non-commercial organization, and there are many other. You can see .biz, .fr, .info, .jobs, .us, many other top level domains are available. Uniform resource locator uniquely identifies a web page. Like, for example, let me say here, let's directly jump here. So you have http://google.com/about/carrier/index.html. This is a uniform resource locator that actually gives you a particular web page, right? So it has few things: the protocol, right? The web hosting page, and the folders and the name. So here you can see HTTP is a protocol. Protocol are set of rules for communication, that how you are going to communicate, what are the rules based on for which you are going to communicate with the server. That is called a protocol. We'll see a bit of detail in coming lectures. But for now, HTTP is a protocol, hypertext transfer protocol, that we use to communicate or access a web page, right? A web resource. Google.com is a domain name, right? That corresponds to the Google server computer, that whenever you have a google.com, it has an IP, it calls an IP address. It is mapped to an IP address of the Google server. /about/carrier are the folders where the web page is stored. What web page? Index.html. So in order to access this complete is called URL, uniform resource locator. It's a uniform, it's uniquely identifiable resource, and we use this is a complete structure for the URL. An email address is for identifying the human. It is basically consists of the username and @ symbol and the providers, right? At gmail.com, at fiu.edu, and many others are there, right? And how actually it works, cloud computing, so your resources are stored on the computers in the cloud of computers rather than on users computer. So your emails are stored on the cloud. That's the reason we can access it anytime, anywhere, because even if we do not have our own computer, you can access it at any computer, right? The reason is because they are stored on the cloud. So resources are available on demand, accessible to any web embedded device. So cloud data is safe. If the device is lost, your personal device is lost or stolen or damaged, you can still access your documents, or you can access your emails back from the cloud server, right? One of the example is the Google Docs and the Google Drive. And how to surf the web, we already know that you need a web browser, and you can simply type the URL in the web browser. You can search using the search engines, whatever you want to do, like the google.com. You can simply search many things from there. For the email, you can use different softwares, and you can send and receive the email using Gmail, the Outlook, and many others, right? So how this technology is impacting on the society, there are several benefits. The vast improvements in technology over the past decade have had a distinct impact on daily life, at home and at work. So benefits of the technology-oriented society include design before construction leads to safer products. So you can actually simulate the product before before its construction. You can design it and simulate it. For example, the COVID vaccines, right? So the vaccines are designed in order to before the construction, they were designed, they were tested using the computing technology that is more safer than testing physically. Or another construction example is you can have a building design using the computer. You can put a pressure on that using simulation, and you can see what it will impact, what would be the real impact. You can design an aeroplane or a car, and you can see what is the air pressure, what is the wind pressure, what is the rain pressure, how far it can go, anything you can simulate before the actual design. So earlier mechanical diagnosis and more effective treatment. With the help of this technology, we can diagnose many diseases at the early stages. That was not possible without the technology. And for that, we can have better treatment. Many examples are there. For example, the cancers, specifically the breast cancers, we can diagnose it at early stages with the help of the technology. For example, diabetics, for example, retinopathy, many diseases are there. So devices that allow physically and or visually challenged individual to perform job tasks. So technology enables differently abled people to work and compete in the challenged environment. So documents emailed or faxed in a moment. You can send the documents any corner of the world in just seconds through the email or the fax. You can download information, movies on demand whenever you want. If the technology has the benefits, it does have the risks, right? So risks of the technology oriented society is stress and health concern. People are getting more stress, and they are getting more health issues because of this technology. Like, for example, the people who are working only on the computer online, they might face the eyesight effects, they might have the ergonomics, many health issues could be, many health risks are involved with this technology. Security issues, computer viruses and the malwares, you guys are actually the security professionals. You are going to design the policies for the for the computing users, right? So you can see identifying theft and phishing. A lot of your information is being stolen. Your data is on the risk. Your personal identity is on the risk. Because you are on the internet and connected with the network, your personal information is always on risk. So security issues are there. Privacy issues are there. We get a lot of spams, emails and the spam requests. Our data is being collected and we do not know how it's being used. So, for example, being an individual, you may have the concern. Being a business, you may have the concern. How your data is being kept and how your data is being recovered. How much is it secure? For example, you are giving your data to create an online account at a particular web page or the website. So your personal data is there. So how it is being stored and how it is being secured, that is one of the concern, privacy concern for the technology oriented society. It also create differences in online communications. So it's less formal than the traditional communication, right? So because of this online communication. So there are etiquettes for the online communication, meaning that we have to be polite and considerate of others. So refrain from offensive remarks. So we know that abbreviations and emoticons are oftenly used nowadays. So instead of being formal in the online communication, actually making us more informal in the social environment, in the social media environment, right? Here is a list of the etiquettes that you can simply read it out, that what should be the reaction or how should we react upon a particular action. Another thing is anonymity and the integrity. Anonymity is, online communication can be anonymous. You do not know whom you are going to talk with. That could either be a fake person, right? So, or the anonymous person. So anonymity gives many individuals a sense of freedom as well as a sense of threats, right? So you do not know. I mean, if you can be anonymous to someone, that's the freedom. But someone is going to be anonymous to you for a particular thing, that can be a threat. So online anonymity can also be abused. So information integrity, use common sense when evaluating online content. So check your sources. Not all information on the internet is accurate. So double check information before using it or passing it on to the others. Right. So what we have learned in this first module, here is the summary. We saw that how the technology is impacting or is available in our life, what actually is a computer and what does it do. We saw that what are the types of computers that fits everyone's need. And then we saw what is a computer network and the internet and how we are going to connect with it and how we can take the benefit of it. And at the last, we saw what is technology oriented society, what are the benefits, what are the risks involved with that. Right. So with this, I'm ending up this lecture and we'll see you in the next video lecture.